is that with the AI algorithms that are being developed at the moment, we can analyze more with less power or less energy. And in space, on our small instruments, we don't have a lot of power available. So it means that with the power we have, a few watts, we have to find means and ways of getting the most information out of the data that we can. And we really see that AI really helps us getting more information out of the same data using a fixed amount of energy, a fixed amount of power that is available.
Hey, SpaceWatchers. This is Space Café Radio, your channel about trends, great people and awesome events. During the IC 2022 in Paris, I had the chance to meet my today's guest and learn about him and his company. I have to admit that I didn't know him nor the company before, even with spending decades in the sector. But what I learned impressed me a lot. Fast forward to today. His company celebrates its 25th anniversary this year. Reason enough to learn more about Cosine and its founder and managing director, Professor Marco Beijersbergen. Join me in this conversation about physics, square fiber cables and AI. I'm Thorsten, publisher of SpaceWatch.Global. Let's get it on. Marco, thank you very much for joining us today amidst your very busy schedule. As Cosine recently celebrated its 25th anniversary, you're undoubtedly the best person to discuss the company's journey over the past 2.5 decades. So what was the catalyst behind your decision to establish Cosine?
I worked for a few years at ESTEC for the European Space Agency, and we were developing exciting new technology to bring into space for future science missions, for future planetary missions, astrophysics missions, and working together with industry and academia on trying to develop this new technology, but also bring it to a product that you can actually launch into space. And then I really had this feeling that there was something missing, a party that could actually bring that together, that could bridge the gap between academia with an interest in researching things and industry with an interest to manufacture things that are already there, and especially in the space context. So I decided to start Cosine as a company that would focus on developing this new technology together with academia and industry to really try to speed up the process of getting new technology into a form in which you can really use it. And because in space, you normally don't need millions of units, and it's usually only one that you have to manufacture. Actually, there is room there for academia and industry to work closer together to create something that's really new. And I really wanted to help that with a company and being able to pick up projects to speed up that process.
We talk about the last century, the last millennium. When you started the company, there was no new space. There was no new entrepreneurship spirit out. What kind of technology are we talking here about?
We had this gut feeling that there was much more to do. One example is that ESA was at that moment working on the largest space mission, also in planetary science, and they became bigger and bigger and bigger and took longer times to get done and more money and budget overruns. And at ESTEC, we were actually working at ideas and also really developing that. And in the first years in the company, we also worked a lot on that for planetary missions to make it smaller, simpler, to think of ways of making that much more simple and faster and much more accessible. And not only to the largest missions, but also to smaller missions. And of course, in the back of our mind was already then that maybe if we would succeed in this institutional environment of ESA to make it smaller, to bring it to timescales of 1 or 2 years, that this might actually also bring a lot of commercial opportunities and to make these missions much more operational than the big science missions that ESA was working on.
The name Cosine, I mean, we all know from our math lessons in school, is quite unique for a company. Could you tell us the significance of the name and what it represents to you?
Cosine stands for the mathematical function, and which is about circling, things that go around, things that go back, that go up and down, but also that go in an orbit. The cosine is the most important function describing a circle. So it's also about satellites orbiting the Earth or modeling basically reality in mathematics. So using a very simple thing like a cosine function can really describe enormous details in nature and in technical solutions. So that is one side why I like this idea that this cosine of, say, the physicist approach of building a mathematical model to predict things in reality that can actually bring you forward. At the same time, the name also comes from the fact that I, at that time, really believed that the computing part is an intricate part of any kind, certainly of instruments, of if you want to measure something, if you want to detect something, it is a combination of a sensor and the computing power to do that. But also if you want to design something, you really have to calculate it. So it's also kind of a contraction of computing and science. So I also started the company with the idea to develop new technology by building computer models. And these days we call that digital twin. My idea at the time was, and we were working on large projects with ESA, to really use computing power in order to design new solutions, to develop new technology, but also to make more out of the data. And this combination of computing and science, computing, science, computer science, cosine, I thought, wow, that is a nice combination, which is nicely abstract and at the same time has this meaning behind it.
Nice. So you came up with this name, or was it a team effort?
No, I came up with this name over Christmas, and I had already decided that I wanted to start a company. So then over Christmas, I thought of this name and then went to our local Chamber of Commerce early January to ask whether this name was already used and how it would work to start a company. And then they said, no, the name seems to be available. Is it not better that we just start the company immediately? So I said, well, is that a problem? They said, you have to pay annual fees to us. That's all. So I said, okay. So they pressed the button and then cosine was actually established.
Okay, that sounds very easy. Reflecting on the past 25 years, which of the many accomplishments stand out as highlights for you and which achievements made you proudest?
I'm really proud. Yeah, but actually, if I look back, I really see that two of the major things we're working on really started 25 years ago in some way or another. And that has evolved into what we're doing now. And therefore, what for me really stands out is that we have been able to develop a completely new technology for X-ray mirrors in order to build a large X-ray telescope for X-ray astronomy. And that started with ideas of how could you make these mirrors in a more efficient way, discussing with my colleague Marcus Bafdart from ESA, how are the others doing that? And then start playing in the lab with plates myself, with gold foil that would fall off and in an improvised clean room. And that has made it all the way into a really nice new technology, which is perfectly suited for this application, which did not exist at all before that. And that is really, I think, at the peak of what technology can do at the moment. The equipment that we use is state-of-the-art semiconductor equipment that we use in order to manufacture these mirrors. And I'm really proud that these first ideas that we had, it shouldn't be that difficult. And if we choose this solution, what would be the real problem? We guess it might be the internal stress, or it might be that. And I'm really proud that by thinking about it and then playing in the lab, we have been able to develop a completely new technology with a fairly small team. This is not hundreds of people. It's not like the development of EUV lithography, for example. It's at a much smaller scale, but still it is groundbreaking technology that did not exist before, that we brought to a level that we can actually build the largest X-ray telescope that has ever existed, and maybe not even for the European Space Agency, but also maybe for our international partner. So I'm really proud that these first ideas of thinking and back of the envelope calculations and this creativity has really led to a real technology that we now have here and that we can manufacture mirrors for. And we're really ready to build this telescope. Second one that I'm really proud of, we already touched on it briefly, is that we have been thinking for planetary science, how can we make these instruments simpler? I actually once wrote a proposal to ESA to just launch a mobile phone. I don't think the first iPhone was out yet, but the technology is all there in order to have a really miniaturized, high processing power imaging system. And then the question is, why don't we fly that in space? What I'm really proud of is that these first ideas of there should be means and ways of doing it much simpler, cheaper, faster, by taking a different approach, by maybe combining things and not having separate instruments for everything, but also taking standard components, commercial off the shelf. Instead of developing everything specially for space, you can also turn it around and take what you have and try to make it fit for space, the other way around. And I'm really proud that over these years, we managed to bring that from first ideas and calculations, computer models for miniaturized instrumentation in space, all the way to being at the forefront of having small cameras that you can fly on nanosatellites, our Hyperscout product, that also has the onboard processing, is even doing onboard artificial intelligence processing now. And that really has led, and there are many in orbit at the moment, and that we came all the way also there from these first ideas of how difficult can it be? Why don't we do it in a different way? That we got it all the way to actually now have it up there and flying and really outperforming in its own niche, in where it's best at. That it's really performing very well there. I'm really proud that we managed not only to come up with the ideas, but also really to bring it to reality and to really turn it into a product. And I think it's still early days in space for this kind of missions and to really make them operational and commercial use of Earth observation or operational use. But I think it's really going very fast now. And I'm really proud that we were at the origins of that.
As you talked about the company and the company size and the small team behind, where does Cosine stand in terms of employees, count, revenue, and ongoing projects? So where are you today?
Yeah, we are at the moment about 50 people. We have our main location in the Netherlands, but we also have a location in Berlin where we have 2 people working. And we're building up at the moment also capabilities in Italy. And we have a turnover of a bit more than 10 million euros. And we really focus on not doing everything ourselves in-house. So we outsource a lot of the manufacturing and of the detailed engineering. And we really try to be the team that comes up with a new bright solution, that does the architecture, then works with industry in order to do the realization. And then we all put it here together and we put on the software. And that comes back to the computing and science, that in order to really get it then to work, the intelligence is actually in the software that is on there. So that we have the facilities in-house to do the assembly, the integration, the testing, and the calibration. And we outsource the manufacturing of the parts and of the electronics. And I really like that role because it means that we, in many of the projects, we actually work with a lot of other parties that are much better in doing these things. And we don't have to do everything of that in-house.
I can hear your enthusiasm and your energy that drives you forward. Over the years, you must have had several memorable experiences. Can you share a particular, very special anecdote for you when you discovered whatever treasure island or you found this magic thing?
Of course, there's so many anecdotes over the years. One example, what I always remember is that's a silly one. It's not one that's something we discovered, but that was really a magic moment is when we had the first Hyperscout in orbit and we were looking real time at the first images coming down. And then the image was black and there was nothing showing up and it was a completely black screen. And then after a few minutes, the bottom of the image was transmitted by the satellite. And then suddenly we saw the first part of the image. And what it turned out is that there was a small timing error in the system. And therefore the image was shifted all the way down. But fortunately, there was a small strip of the image visible that was of Scotland. So we could see the first images and we immediately knew what the problem was in a few seconds then. And then with one software upload to the satellite, we could actually fix the problem. And after that, got beautiful images from the first Hyperscout only a couple of hours after launch. And it was really a special moment because we had worked so long on getting this whole technology working and testing it in the lab and hoping that the launch will go okay. And then an enormous disappointment when you see an empty image and then suddenly there's first light. And first light is always a magic moment that I know from the huge ESA satellites where suddenly there's a whole PR event where you have first light. But we were just looking at the screen, saw the data coming in real time, and then really saw the first pixels with light in it showing up. Another example of a magic moment was that, and that's really at the origins of our X-ray mirror technology, is that we were working together with a French company that is producing glass fibers, and we were doing a special project to manufacture square glass fibers, also for X-ray optics. It's a very special technology where you make very thin square glass fibers out of a thick glass block. And you do that by heating it in an oven, and then you pull on it, and then you get a very thin glass fiber. And that actually should then also, if you start with a square block, you should end up with a very nice square fiber. And in production, they were trying to measure a little bit on these fibers and to see whether they could improve the quality. And it was really early days for Cosine. And we really had this feeling of it should be possible to measure much more with a bit of light, with a laser beam on it. So We got a piece of this fiber, we turned off the light, shone the laser onto the fiber, and then looked at what happened with the laser beam. And then we could immediately see in the dark on a piece of paper that you could actually see an enormous amount of information by just shining a laser beam on this piece of glass. And you could see whether it was twisted, whether the surfaces were flat, whether the angles were square, whether the fibers was bent or straight. And actually, we were trying in the factory in France to improve the production process, but then suddenly by just shining a laser beam on it, we could get so much information that we really realized now we have the key to really improve the performance of this manufacturing, and we can really now make much better fibers, and we can help them in the factory to improve their process instead of just trying to keep the quality that they had and really get beyond what they had. And that technology actually resulted in a huge uptake for the Bepi Colombo mission to Mercury, so actually flying in space.
Stay with us. We'll be right back.
Moving is right up there with death and divorce in the Stress Olympics. But fear not. Turn that box of woes into a crate of woes with moving tips in the Life Beyond Boxes podcast with Premium Q Moving. Dive into the world of hassle-free moves, learn tips and tricks to save on cash and your sanity. Say goodbye to those moving meltdowns and hello to the smooth sailings, or should we say smooth movings? Tune into Life Beyond Boxes with Premium Q Moving on lifebeyondboxes.com or find us on your favorite podcast platform, and with us, unpack the secrets to a stress-free move.
The next step is looking ahead. So with an established company as you are and a solid product portfolio already in place, what are your plans for Cosign's future?
We have strong ideas where we want to go. And it's interesting if you look back at these 25 years that, you have to adjust your strategy and your ideas of how things will go. You have to adjust them all the time. So I'm also pretty sure that ideas we have at the moment might change over time. So let's see where we are in 25 years from now. But one thing that we really want to keep is we want to continue growing slowly. We've been growing slowly over the years. I did not want to really go into large-scale manufacturing, completely open up a new market where there's really low level, much cheaper, but much larger volume, where you could maybe make more money. But I think that is not where we can make the real difference. So it's also much more risky for us. So I want to continue growing slowly. But what I also want to do is to stay at the forefront of this measurement technology. And a very important aspect there is to continue being able to get more and more information out of the data that we're gathering with our sensors. Where we will certainly be going is to use much more advanced processing in order to do everything that we are doing on the ground now, to be able to do that in orbit or in the instruments that are used in the field or that are used on airplanes, that are also used in factories that we also develop. I think a very important aspect is that instead of having an instrument that is doing processing and giving calibrated data, we will definitely move to instruments that will tell you there's a fire. You have to do something, or the crop here needs more water because the yield is going down, or that gives short-term predictions on flooding, or that gives you an indication, real-time information on where flooding is going on. And this idea that Earth observation is observation, and then you can do something with the data if you want, really move that into really having systems that are monitoring and that can trigger action, that you get actionable results. And I think we will 25 years from now see that there will be much more Earth observation data available for everybody, in the sense that there will be a lot of services that are based on Earth observation the same way as we have with GPS now, where you can make use of the data that is gathered by satellites or maybe even other systems on hubs or on drones or static systems in the field, combining that data so that everybody, also an individual on his phone, can make use of this information to take action and to have more information about your environment and do something with it. And I think in 25 years, Cosign will be a big player in that market by providing the technology and the tools in order to collect this information and to bring that to a state where you can do something with it. I also think that we will, in 25 years, not only have developed the X-ray optics for the Athena mission, but also for a few other X-ray optics, X-ray astronomy missions. But this also will have led to the development of other types of exotic optics that nobody thought was possible. So, for example, to image gamma rays, and not only gamma rays from cosmological objects, but maybe also in medical applications, that instead of just detecting the gammas, you can also put in a lens and then you can make images with very high resolution. or also optics for particles like neutrons or protons. And that instead of the next step from being able to focus and image with X-rays, that we go all the way to image and focus with other types of particles and high energy radiation. That brings, I think, a lot of benefit to, for example, medical applications, but also material analysis, inspection of all kinds of products, and gathering information about the world around us that at the moment is only available in the laboratory, and then really being able to do that in the field, in the factory, from an aircraft, or maybe even from space, and that you can really collect this advanced data in the field and can already process it so that you don't take the sample to the lab and then have it analyzed and then hope for the best in the real world, but actually that all these beautiful things that we can analyze in the lab, that we also start doing that in the world around us to create a better world around us.
We spoke about your highlights from the last 25 years, but is there a specific project that holds special significance for you and Cosine? And if so, why? Why does it stand out?
I think this, what we call the SPO, the silicon pore optics for X-ray astronomy, that still really stands out. It is what we started the company with, having a creative idea, making a computer model for how to do it. And in parallel, at the same time, we were working on the computer models for the XMM Newton optics, which is a huge X-ray telescope that was launched by ESA in 1999. And I built the computer models for the optics, for the lenses in that spacecraft. And at the same time, we were thinking of what should come after that and what should we do in 15 years. So we did there the computer modeling, we analyzed that, playing in the lab, having the gold foils peeling off and taking it all the way to what we have now, where we have one of the largest ion beam figuring machines in the world, where we can actually, with a single beam of ions, we can remove individual atoms from the surface of our mirrors to really make them the perfect shape, where we have one of the most beautiful coating machines in the world, where we can apply extremely thin and extremely smooth layers on top of these mirrors in order to get more reflectivity, to get more X-rays collected with the same size of telescope from these astronomical objects, to learn more about the history of the universe, how black holes work, to understand better where the gravitational waves come from and where these high energy events in the universe take place. That still really stands out for me. And we also see that for our colleagues, this idea that on the one hand, you're working on very practical technology that will also find its way into medical applications or in material analysis equipment on the ground. And at the same time, you're working on this technology to learn about the universe and to discover the things that we don't know, and that will create a big breakthrough also in our understanding, not only of our environment, but actually of the whole universe. And I think this is really this combination of really practical technical work in the lab, together with having these high-level science projects to work on and also work with the scientists, that has been the origin of the company. And I think that is still the highlight and the core of what we are and what makes us attractive also to work here.
I can't finish this interview with you without talking about new technologies. And you mentioned AI. Given your work that involves not only hardware and sensors, but also data, AI and machine learning are likely essential components for you and your clients. What are your thoughts of the role of AI and machine learning, and how do you see them benefiting us in the future?
A lot of people see AI as something that is completely new and that is, let's say, a revolution. When I was a student, a first-year physics student, I built a neural network in the small, one of the first PCs that were around at the time, and playing with that. And then we also already then realized that this is a way of processing data. It is a way of doing statistics, of analyzing data that you already have in order to match things or find relations. And for me, AI has always been the logical next step in processing data, from first making graphs and fitting maybe a function to it. Then you do statistics. And then the next step is that you feed your data into a computer model. And then you use this computer model in order to make predictions. And if you have an algorithm that can feed this data into the model, that is the logical next step. And for me, that is AI. And therefore, I think that AI will be the logical next step, in the sense that, in many situations where there's a lot of data which is difficult to look through, AI can really help us to get to the next level where we already have developed a lot of tools. I do think that AI over the last few years has been a bit the idea that it's a black box, and if you have a lot of data, you stick in the data and then it will find relations and it will give answers. And we have done a lot of AI projects over the years. We have set up a spin-off company that is doing spectral imaging in the food industry on food products, and they use a lot of AI. And we're also doing a lot of AI for our remote sensing instruments. And actually, we are the first ones to fly AI hardware, neural network hardware in space. On our Hyperscout, we have an AI board that is doing neural network processing of the images in space. And we have demonstrated the first applications with that and now are developing the real ones. The lesson that we have learned is that you have to be really careful with the quality of the data that goes in. You have to really understand the data that goes in. And that for me as physicist means that it has to be calibrated data. So you have to convert it into real units and it has to have a meaning already. And the second one is that the more knowledge you put in the AI of the system you're looking at, the more understanding you can already provide as a human being to how you build up the system, the better results you get on the back end. And that, I think, is going to be fascinating because, of course, also that you can turn into AI and you can teach a machine to do that. So I really see AI the same way as the steam engine was an extension for our manual force, and that we have learned to master that in order to do things as human beings that we were not able with our own muscles. That I also think that AI will play a big role as an extension of our brains in order to see things, to analyze things, but also maybe even to take action and to take decisions that are still inspired by us and that we decide on how to train it and what to train it with, but that can act as an extension of our brain. And what we see in practice is that with the AI algorithms that are being developed at the moment, we can analyze more with less power or less energy. And in space, on our small instruments, we don't have a lot of power available. So it means that with the power we have, a few watts, we have to find means and ways of getting the most information out of the data that we can. And we really see that AI really helps us getting more information out of the same data using a fixed amount of energy, a fixed amount of power that is available. So that means that, it will lead to much more efficient ways of doing that. So I really think that it's the next step. It's something that will happen and that we should also use. And I think it's important that people have a good understanding of that it's still really determined by what you put in and what you feed it with. And that really determines and how you set up the system. And that really determines what comes out. So if you see it as something that can also have negative consequences, then we have to really think hard of what do you feed it with. And I think in that sense, it's not different from what do you tell people and how do you train and educate them? And we have to think the same way about how we develop our algorithms, because these algorithms are much more sensitive for how you educate them and how you train them and in what culture they are operating, the same way as we as human beings do, and that we have a strong influence over that. And I think it's not going to go away. It will continue growing and we will learn how to work with it to make the best out of it.
So there are, in your environment, no concerns of using AI. We see, on the contrary, ChatGPT and all these developments into a mass market are concerning people more and more. But as you work with AI in your contained environment, you see just the benefits of it, correct?
I think it was hidden already a bit in what I said, that I do see risks, that you can use it in a way, if you feed it with the wrong information, if you educate it the wrong way, it can also give answers and act in a strange way. And in that sense, it's, that is also a bit similar to a human being, but it's not different from the expert systems that have been developed over the years that were not based on neural networks or machine learning, but that were based on statistics or other things. Also there, we have seen a lot of mishaps by misinterpreting data, by taking the wrong decisions based on data and an algorithm. And that is not different. It is just scaling up and going faster with AI. So yes, there are a lot of risks, but they are not fundamentally different from the risks that you see in another environment where you have data and algorithms in order to take decisions. And I think people have underestimated more the risk of that what was already going on, what we used to call big data a couple of years ago, which was the hot thing. And with AI, I think the risks are even larger. And I think what you mentioned, one particular risk is that with the AI, the level that we have achieved at the moment, it becomes difficult for people to discriminate whether it comes from a human being or it comes from a machine. So it is very difficult for us to judge the origin of something that you see coming. But I think in a way that has always been the case, because also people use data and algorithms to take decisions and tell this to you. Yeah, this is also in any expert environment, this has always happened. And we have to learn also how to deal with the decisions, the results, the outcomes that these systems give, the same way as we have to learn that we have to be careful doing that based, for example, on statistical data in the medical world or on predictions for earthquakes, and which were not based on AI, but have these same risks.
I see your points. We are not continuing this conversation about liability of machines taking decisions versus humans taking decisions. That will be a great subject for another conversation.
Yeah.
But Marco, you talked about the future you can envision for the next 25 years for the company. Where do you see yourself within this time frame?
What I hope is that I will get a chance to use the things I've seen and the experience and the lot of inspiration from people that come with questions to use this even further, not only to develop the technology for space, but to try to help also more outside space. We're also doing it as a company quite a lot, but it's a bit less visible. To be able to help people with bringing this, we can measure everything in the lab, to the normal outside world. And to help people with, I would like to have this information, or I would like to measure this, or I would like to get grips on that, to be an inspiration and a help for people to think it can be done and there are solutions to do this. And if we work together with this or that person, we will actually be able to solve this. Because I really see that, if you look at centuries back, when we had no idea about how nature worked, people were afraid of it, and there were all kinds of stories and strange things, and things happened to people. And for example, different kinds of infectious diseases, once you understand how they work, once you can observe them, and once you can detect them, you can actually start doing something with it. And I really feel that I would like to work more with a broader context, to bring this to different fields in society, to see whether we can solve more problems by making more visible for really daily problems and practical problems, not in space for cosmology, but also just on the ground on simple problems around us. I have been doing that for the last 25 years. At the moment, I've put a lot of time and energy into managing the company and making sure that these exciting projects, that we have the right people to do that and the right structure, and that we're able to do that. But I would really like to be able to spend more time on being creative, coming up with new solutions to make these things visible in order, and to be able to measure and detect things in order to help people around us. Because for me, science and technology is not there for the science and the technology, and research is not the sole purpose is research, but really I would like to try and use it more and spend more time on really applying it to a direct result for, let's say, the people around us.
It does not sound like an early retirement you're looking into. Thank you very much, Marco, for your time and the conversation.
Thank you very much.
If you have further questions, reach out to us at radio@SpaceWatch.Global. If you like these or other episodes of Space Café Radio, leave us a rating on your preferred podcast platform. It is the currency of today. And if you want to stay on the pulse of the space industry, please visit our website at www.SpaceWatch.Global and subscribe to our newsletters. And of course, don't forget to become a Space Watcher. I'm Thorsten Kriening, publisher at SpaceWatch.Global, your independent perspective on space.